So we are starting with the type 1 and type 2 error concepts of this particular hypothesis formulation, right? So now what is this type 1 and type 2 error? To get the clear idea of the type 1 and type 2 error, we can say this particular part is this is used in the hypothesis testing. We have formulated our null hypothesis statement. We have formulated our alternate hypothesis statement. Now with this null hypothesis and alternate hypothesis, what are we going to do is whether these statements, whatever experimentation I am doing is by fluke or is it through the real scientific experiment? Does it have the complete support of the analysis and the explanation that we are going to find out in the through the statistical test. As I have already explained in the class also, the steps to do this is what we initially do. See, we initially propose some problem statement. We start developing the algorithm to execute the solution to the given problem statement. Now, once we develop the algorithm, that algorithm is converted into the testable statements or the executed code, and then we start performing the experimentation. Why we perform the experimentation? Because we say that this particular methodology is proposed by me and which is going to give me the accurate and the improved results. So take an example. We'll take a simple example. The simple example is, say, the medical test, correct? Now already, say suppose I'm just developing one of the automated systems which predict whether the given patient is having the fever. Fine. So for what I'm supposed to do, I will be recording the body temperature. I will be recording the current condition, say the throat pain, say body pain, or the headache. So all these symptoms will be recorded. Now, at the end, through my proposed steps, I will feed the steps as okay. The patient is having the temperature of this degree. The patient is having the body ache, the headache. It means that the patient is a feverish, having some fever and requires the dose of the antibiotics. Right? So this I will be doing as the automated process through my proposed model. Now, to verify this, whatever experimentation I have done and whatever results I have got, whether those results are correct with the results of the experts from the given field. What does it mean? I am supposed to verify the results with the doctors also. So the doctor has said, okay, yes, the given patient has the fever. And my experimentation is also saying, yes, the given patient is having the fever. What does it mean? My experimentation result is in line with the expertise domain person, in line with the output of the doctor's opinion also. It means that my experiment is working successfully in this particular case. Now I'm doing all these steps, but but at what extent should I say that these all tests are correct? They are not because of the fluke. Because see, whatever I will perform, that particular experimentation is on the sample. It cannot be on the complete population. The population of India is so huge, or population of any country, any state is huge, and we cannot perform the experimentation on a complete each and every person of this population. It's not possible. So I will be conducting the experimentation on the samples. Then like what is the confidence that samples which I am selecting are not the biased samples? They are random samples. There is a randomness based in the experimentation. So to support this, to support that my experimentation is the right experimentation and it is not because of the fluke, whatever results, whatever outcome, whatever accuracy I'm getting through the experimentation is merely because of the scientific reasons and due to the scientific steps. For this, I perform the statistical test. Now, in this test also, I'm supposed to get few errors. So I will be getting some errors, and those errors are categorized as type 1 and type 2 errors. Now look at the screen. On the screen, you can see the first part is the type 1 and type 2 error. Correct? what I said over here, these errors are related to the hypothesis testing. Fine. Now, here there are two initials which are given, or two labels which are given. On the screen, you can see the first one is my actual result. Now, what is this actual result? The actual result is the one, in our example, say the doctor's opinion is the actual result, because the doctors are the expert people who actually identify through the symptoms, through the various tests, the blood test, through say various scans. The doctor is going to say about the existence of the disease, right? So those are my actual results. Correct. So those are called as actual results. Please remember in this very well manner, the expert's opinion is my actual result. Right. Say I am doing the classification of dogs and cats images. Correct. A very simple experimentation. I have the images of dogs. I have the images of cats. Through my proposed experimentation, through my algorithm, my machine is going to classify the dogs and cats automatically. Right? There is no human intervention. Correct. So in that case, what is the actual result? The actual result is the manual result. I, being a human being, I'm able to see whether this image is of a dog's image or whether this image is of the cat's image, right? So I will be manually classifying them. Those are my actual results. And whatever I am going to get through the experimentation, through the automated process, is the decision. Correct? Is the result of the experimentation. It's the decision. I hope you are clear with what is the actual results and what are the decisions. The actual is the one which is through the expert, which is through the human intervention, which is through the manual scanning. So that's my actual result. And what is the decision? The decision is the proposed, what is the outcome after the execution of the proposed algorithm through the automation, how this particular proposed algorithm works and whether it also gives the right results of the classification of cats and dogs. It may happen that the cat is a little fat and little chubby, right? So it may happen that the cat may be depicted as the dog because of my proposed algorithm, the steps of my proposed algorithm. But in actual, that cat is a dog, right? So this is the difference between the actual and the decision. And this difference, this wrong result is my type 1 or type 2 error. I hope this is clear with all of you. So we'll again go back here. So here you can see that this is in the green color. This is my true negative and true positive. Correct? Now, whenever you have the statements like this, the true negative, true positive, false negative, the first task which you are supposed to do is you are supposed to expand the statement. So expand the statement as truly positive. Expand it as a truly negative. Falsely positive, falsely negative. When I say something is truly positive, it means that it is a positive and the experimentation has also said that it is a positive. So that's my truly positive, right? What does it mean? I would say that a patient is having a fever. The doctor has said that a patient is having the fever. And through my automated process, after giving the data of all these symptoms, my machine, my algorithm has also said that the patient is having the fever. So what does it mean? There is a positive result from the doctor and there is a true result from the experimentation. So what does it mean? The experimentation has supported the doctor's decision, or vice versa, the doctor has supported the experimentation result. So that's my true positive result. I hope true positive is clear with all of you and there is no doubt. Now we'll go to the true negative. The true negative is also same. There is no fever, there is no disease is my negative. Correct? And when the experimentation also supports that there is no disease. So it is also supporting the negativity, and that's the true support to negative results. So it's my truly negative. I hope this is clear with all of you. Whenever you want to understand the concepts of true negative, true positive, false negative, you should also always remember some test. Say the test of the diabetes, say the test of the cancer, say the test of the fever. So when we take this test in the mind, or some the medical, the example, the real life example of the medical domain in the mind, then we understand this concept of the true positive, true negative in very well manner. So what is truly positive? Truly positive is my, I have the disease and which is supported by the experimentation. That's my truly positive. When I say true negative, that I do not have the disease, the doctor has, through my symptoms, the doctor has said that there is no disease and it is truly supported by my experimentation. So it's my true negative. So true positive and true negative are the two successful conditions, right? Now we will move to the erroneous condition. Now what is this erroneous condition? Let's see the erroneous condition. So my erroneous condition is false positive. Correct? The first condition is false positive and the next one is the false negative condition. Now, when I say the word false positive, you expand it as falsely positive. What does it mean? Falsely. It means that by some wrong, which wrongly it has come as a positive. Correct? When I say the falsely positive, it means that wrongly it has come as the positive. So that's called as the type 1 error. What does it mean, a wrongly positive? It means that, a simple meaning of it is, it means that there is no disease, oh, there is a disease, but I have failed to detect the disease. My model has failed to detect the disease. Correct? See, I will again repeat, it is a falsely positive, correct? A falsely positive or the type 1 error. What does it mean? It has given a falsely positive, correct? What does it mean? There is no disease, there is no disease, but it has been given as the positive through my experimentation, right? So it's a falsely positive. It has come a positive with the wrong prediction. So falsely positive answer aa gaya hai uska. I hope this is clear with all of you. And there is a false negative term also. That's my falsely negative. So it is exactly opposite with the falsely positive. What does it mean? There is a disease. There is a disease, but it has been said as it's a falsely negative. So there is a disease, but my experimentation says that there is no disease. Are you getting this? There is a disease, but my experimentation says that there is no disease. So again, I will repeat the falsely positive and falsely negative. False positive, false negative. So how I'm supposed to understand these two terms? Whenever I get a term as a false positive, I will be expanding it as a falsely positive. So wrongly positive answer aa gaya hai. Correct. What does it mean? It in reality, it is a negative. In reality, it is a negative, but it has come as a positive. What does it mean? There is no disease in reality, but through the experimentation, my somewhere I'm lagging the experimentation. Somewhere my model is not built up to that extent. So because of some mismatch steps, because of some mistake in my model, this particular answer is coming as a positive. So it's a negative answer, but it is coming as a positive. So I will be calling it as a falsely positive. This is called as a type 1 error. You can see it in very well manner over here. It is called as a type 1 error. False positive is also called as the type 1 error. It is denoted as alpha. It is also called as a significant level, and that is called as a alpha. Correct? In a similar manner, I will be calling this false negative as type 2 error. Correct? It is failed to reject, and it's denoted as beta. Correct? It is denoted as beta. So my true negative will be 1 minus beta, and my true positive will true negative will be 1 minus alpha, and true positive will be 1 minus beta. So this is all about my type 1 and type 2 error. We'll move to the examples of this type 1 and type 2 error in further manner. So example, we decided to get the tested for the COVID-19 based on the mild symptoms. So there are two errors that could potentially occur. So it's my type 1 error. What does it says? The test result says you have the coronavirus, but actually don't. That's my false positive. I hope this is clear. The type 1 error, the test result says you have the coronavirus, but you actually don't have. Correct? And what does the type 2 error says? The type 2 error is my false negative, and the test result says you don't have the coronavirus, but you actually do. That's my type 2 error. Correct? So this is a very strong example of the type 1 error and type 2 error. There are few more examples of the type 1 and type 2 error. So what we have to do is first we have to define the null hypothesis and alternate hypothesis, do the experimentation, and then through the careful experimentation, I will be then verifying it with the actual results, and then I will be finding out my type 1 and type 2 error. So type 1 error happens when you get the false positive results, where you conclude that the drug intervention improved the symptoms when it actually didn't improve the symptoms. Okay. And then we have the type 2 error happens when you get false negative results. What does it mean? We conclude that the drug intervention didn't improve the symptoms when it actually did. Correct? So these are my type 1 and type 2 errors. So the graph shows, this is my graph, a normal curve graph. Okay, over here you can see the type 1 error probability at the graph. Just a second. Let me clear this, clear all. Okay, so here you can see that this is my type 1 error rate, which is my alpha. So here at this place, this is generally taken as 0.05. So how much confident I am that I will be getting the right results to the experimentation. As I already explained you in the class also, that many times I say that 99.99% I am confident that my proposed algorithm works. Or the doctor says that 99% of the times the given say the medicine works for the disease successfully. It is observed that say 99% times that the error is cured because of this medicine. So what does it mean? There are still 1% chances where the particular medicine has failed to cure the disease, and that 1% chances are this alpha. You can see over here in the graph, there is this alpha. So this 1% chances, which is when I said it is this alpha. Correct? So that's my null hypothesis H0, and this is the place how I show my type 1 error. Correct? So now move to the type 2 error. Let's move to the type 2 error. So this is my type 2 error, and it is shown as the beta. You can see here it's a beta, and the beta shows the like it is again the same when I say that okay, say 1% chances of the failure. That's my beta. Correct? So here you can say that the type 2 error statistically powered determined by the size of the effect, that is a larger effects are more easily detected. Measurement error, sample size, and the significance level. These are how the statistical power or the type 2 errors are detected. We'll say the trade-off between type 1 and type 2 error. So setting a lower significance level decreases a type 1 error risk. Significance level, which was the alpha. So setting the lower significance level will decrease the type 1 error risk, but again it increases the type 2 error risk also. Even the increasing the power of the test decreases the type 2 error risk, but increases the type 1 error risk. So that's the trade-off between the type 1 and type 2 error. This is how the trade-off between the type 1 and type 2 error is shown. We have the null hypothesis, H0 distribution, and we have that 1 minus alpha, that is my positive results. And I have the alternate hypothesis, which is my H1, which is my 1 minus beta. So you can see here, this is my 1 minus alpha. This is my 1 minus beta. This is my null hypothesis distribution, and it's my alternate hypothesis distribution, correct? So I am getting the places over here, the beta, that's my type 2 error, and this is alpha, that's my type 1 error. So how the probability of making the type 1 and type 2 error plays the role. I hope this is clear with all of you, type 1 and type 2 error. So let's move ahead, and then we'll see how to, there are few examples of this type 1 and type 2 error, as we have already seen, and then how to minimize this type 1 and type 2 error. So to minimize the type 1 error, what I am supposed to do, I am supposed to choose a smaller level of a significance as the beginning of the study, right? By setting the lower significance level, the chances of incorrectly rejecting the null hypothesis decreases, and thus it minimizes the type 1 error. And how I will minimize the type 2 error? The type 2 error can be minimized by increasing the sample size. Sample size जो रहता है, जो हम select करते हैं, we are supposed to have the more quantity of the sample size, or choosing the threshold alternative value of the parameter further from the null value. So increasing the sample size reduces the variability of the statistic, making it less likely to fall in the non-rejection region where it should be rejected, and thus it minimizes the type 2 error. So this is how I'm supposed to work on the type 1 and type 2 error. Is there any question in the type